Hi everyone, welcome to my first real devlog. Before showing you what I've done in the last month or so, I just want to clarify that me and my partners still haven't figured out what game we're going to make. So all the visuals for this video were made for this video in particular, so they might not be in the final game. Don't forget to like and subscribe if you enjoyed the video, and now let's start this devlog. I'm trying to write the cleanest and clearest code possible, but there's going to be a lot of misspelling and other mistakes, particularly in the comment or in the variable names. If you find any of those English mistakes, I'm happy to correct them, so just write them in the comments. So the first important script I've created is the singleton mono behavior. I didn't come up with the script, I actually got inspired from this GitHub repository. The link will be in the description. What's a singleton, you might ask? A singleton is a class that can only have one instance of itself active. So the first parameter the class receives is t, which is the type of the child class. My two only serialized fields are to-boolean, is persistent, and should print logs. Here's the first important part that makes it a singleton, this code right here. So I got my private field, the private static field instance, which is of the type of the singleton, and it's basically the instance I want to keep. By default it should be null because for the game start there shouldn't be any singleton active. Then I've got this public property. So basically it's the same name, it's also the instance, same, and it's public static and same return type. It's basically a way to get this value if the instance is null. So let's say I'm trying to access a singleton but it doesn't exist at the moment. Then I'm going to check in the scene if there is an instance, and I'm storing it as the instance, then I return it. If there's already an instance, I return it. After that, we have awake. I put awake on virtual because the child class might still need to edit the awake Unity function, but as I wrote in the commentary here, it's important that the child class writes base.awake if it needs to execute code in awake, else it's not going to be a singleton. So this part here, if instance isn't null and instance isn't this. Let me check, is there already an instance? If there's already an instance, am I this instance? Because if there's already an instance and you're not it, well then you're a clone and we don't want a clone, so we need to destroy the clone. So if there are no instances, you can continue this way. If you are the instance, then you can also continue this way. I'm just stating that you are the instance, and then I check if you're persistent. A persistent singleton is a singleton that won't be destroyed when loading a new scene, hence why I wrote don't destroy unload this. After that we have undestroy, which is not that useful, it's just a way to print that you destroyed the singleton if you're the instance. Finally, the try print log, it's just a way to print any log if we want to, so if should print is true. So that's about it for my singleton. Next up is my attack system. My attack system is divided into two interfaces, the damage dealer and the damageable. Damage dealer is an object that can deal damage, hence you have damages as a property. Damageable has an health, can take damage, can resist to stuff, because you can change the health, there's thing with events, and it can die. Now we're looking at the detection system I wrote, which is basically a system that can keep tracks of all the game objects inside a certain zone and detect whenever they leave and join the zone. It's divided into 4 components: the eye detectable interface, the eye detectable disable interface, the eye detectable element interface, and the detection zone class, which is abstract. The eye detectable interface is empty because it's just an interface to use as a tag to say that a game object can be detected. Next up, there's the eye detectable disable interface. This interface inherits from eye detectable, and it's to use when game objects can be deactivated while inside a zone. And it simply has an event called undisabled to launch whenever the game object is disabled. After that, there's the detectable element. The detectable element is simply an interface that keeps track of a detectable, and it's used by my detection zone to keep track of each of the detectable in the current zone. And the last part is the detection zone. The detection zone is a mono behavior because I need some functionality from Unity, and because it's a mono behavior, it can be an interface. It's a generic class that takes in 2 parameters. The first one, which type of detectable you want to keep track of, and the second one is which type of detectable element you want to use. To begin with, the child class must define 2 functions. The first one is try get eye detectable, which takes in as an input a game object and returns a boolean and the potential eye detectable component. The other function is create eye detectable element. It takes in as an input the eye detectable component and it returns the detectable element. Then there's 2 functions that the child class can define if it wants to: unenter and unleave. Both of them have as an input the eye detectable that just entered or that just left. Then you've got the list of current collision, which is a list of detectable element, and that's basically all of the current game object in the zone. The rest of the code is the logic of how it works, and it uses both onCollision and onTrigger, because I want the code to work either if the detection zone is a collider or a trigger. Whenever a collider enters the zone, you check if you can get an eye detectable component from the object, and if you can't, you gotta return. Or if you can find one, but it's already stored in the current collision, then you return, because the eye detectable component is already inside of it. If it's a new one, well, if it can be disabled, you gotta subscribe to the event, and you add the new detectable element, and you execute onEnter. Then on leave, it's pretty similar. Whenever you leave, you check if there is an eye detectable component on the game object that just left the zone, and if there's one, you check if it's in the current collision. If it's an eye detectable in the current collision, then you can remove it from the list. When you remove a current collision, well, because I take in as an input the index and the eye detectable element, I start by removing it from the list. Then I check if it's detectable, disable, and unsubscribe if it is, and call the function onLeave. How do I check if eye detectable is inside my list is like that. I go over each item, and if the eye detectable stored inside the collision is the same as the one I gave in as an input, I store the index and return true. Else I store a negative index and I return false. Finally, whenever the game object is disabled, I call a for each loop over all my elements in my collisions, and I call onLeave, and if the element is eye detectable disable, I unsubscribe. And after that, I clear my list. So that's it for my detection system. As you've seen in the short clips at the beginning of the video, I've made some code to generate primitive structures and a procedural terrain but those aren't completed, and I don't want to show the code until it's fully done, fully completed. Also, it requires a lot of mathematics, like a lot of other scripts that I couldn't show because they're basically math. So I might do another video just for the math behind how primitives and procedural terrain work. But yeah, there's not going to be any code for this at the moment. If you got any comments, any recommendation for me, feel free to leave them underneath the video. It was PBandit1, out.